Welcome to NAB. We're here at OpenDrives, once again demoing a full live demo on our gear, on our Atlas operating system here on the show floor to show that we work amazingly with media workflows. In this case, this year we brought an Optimum system with a full C module, an F module, and two H modules to drive the performance we need from these systems. From here, all of the rooms within this booth are all working concurrently off of that same storage system to prove that it's not smoke and mirrors, that we're providing the demo, we're providing the content, and we're running those really difficult media workflows that our customers have. From there, Adrian will present the full demo of what an experience of those workflows, use cases, application will be, and we'll go from there.
Yep. And one of the things I like to point out is we have a relatively small amount of equipment compared to what our competitors would need to use in order to play back some of the content we're going to be showing here today. And that really is part of the differentiator between OpenDrives and everybody else. So how we're moving data between these different hard drive capacity tiers, the H modules that James mentioned, moving those into NVMe and then out to the client is really where we're gaining our performance in a small amount of footprint here, a small amount of hardware. And that's going to provide cost savings, significant cost savings to our clients. A lot of the competition out there has the ability today to mix and match NVMe and hard drive, but they move data at a file level. So that means that I have to copy my entire project's worth of files into my NVMe in order to be able to sustain anywhere close to the level of playback that we're doing here. We don't do it that way. We're actually promoting the blocks into the NVMe layer, meaning we can make that really small. We don't need to over provision there. Everybody knows NVMe is exponentially more expensive than hard drive, especially in larger situations where you might be approaching petabytes. You don't want to have a petabyte of NVMe. We can provide that all flash level experience in a very small amount of hardware. So this gives a cost savings to our clients. It also helps the end user. It helps our administrators. If you give your editors the option of, hey, you have two tiers of storage, your really fast one or your dense one, where do you think they're going to put their media? What's going to fill up first and what's going to be the most expensive to actually continue to grow?
Yeah, absolutely. And as you can see here, there's a whole lot of hard drives within these two H modules, only a few NVMe drives. We take a chunk of the RAM pool, a chunk of the NVMe, and then the hard drives, and then obfuscate the differences between those, create a logical pool, and it's all of Atlas, all of the software that is dealing with where that data is and where that resides to then drive that to the customer. I think that's a differentiator there in that we came after SSDs, after flash storage it was a staple. And whereas a lot of the other systems are, let's take advantage, we bolt it on to an already established architecture. Ours is designed to look at the data, to look at the usage, and make sure you're getting that low latency, flash-like speed, and never really being bound to the slowness, I'll say, of these 3.5-inch actual hard drives.
Yeah, and again, you're going to see a similar theme as we go through everything. We want our creatives to be creative. You edit. We don't need you to be an IT person. We're going to be handling that data movement in the background. It's all done algorithmically. You don't have to, program anything to move. You don't have to manually copy everything. Atlas is handling all of that. So let's kind of jump right in. So we're going to start off with just talking about how we're splitting up and how we're using some of that media. One of the unique things that we do is we're actually able to utilize some of that NVMe. So in that diagram before, we had 8 drives. 4 of those drives, we create a dedicated pull for and share, specifically for applications that can point cache databases and the like. So Adobe Premiere, DaVinci Resolve, we're able to point that data there. That provides us with a number of benefits. Number one, anybody who's ever worked in a Premiere sequence, for instance, in one edit suite and needed to move to another edit suite and open up that same project, you're in for a very long, painful time of having to regenerate all that cache content. Time equals money, obviously, and we've got clients that, you click on a sequence and grab a cup of coffee and, wait for it to actually open.
Yeah, you see that there's a little bar in the bottom screen where it's trying to make all the thumbnails, all the peak files, all the waveforms, and that tends to interfere with some of the creative process. So they wait for that. Well, think about that. Every workstation is doing that. In this case, it's done once and everyone benefits from that. So you're really just getting into the creative mode immediately.
Okay. So let's go ahead and show that. So if
Yeah,
I go into
absolutely.
Adobe Premiere, this is a feature-length film. This is typically where people have really had that pain in any kind of long format content or content with a lot of objects in it. You go ahead to open that, and as mentioned before, it take many, many minutes for you to open. We actually had a client of ours now that saw this. They work on home renovation videos, and they told us it takes them tens of minutes from opening up their project to actually having it fully loaded and being able to work. This is loaded before I'm able to even finish that sentence, about 30, 40 seconds. We're up and running, saving minutes of time from actually, clicking on the project to working, meaning I'm getting to my creative process immediately. I'm not having these things and these annoying processes take away from that.
Do we know that the editors like that though? Because usually that was a built-in break for them to go and get like a coffee or something.
The
So,
management likes it, but the
okay.
editors don't like
Yeah,
it. Yeah,
absolutely.
exactly.
That's what matters, right?
Yeah. So you can see we have everything fully loaded here. I can go ahead and play down. This happens to be a 2K sequence, so that's great. What everybody at the show is talking about 4K, 5K, 6K. So let's jump into something a bit beefier to show that level of performance on the platform. So if we open up DaVinci Resolve, this happens to be a 5K Blackmagic RAW sequence. So here we're playing down the content. I got my little real-time indicator showing that I'm not dropping any frames as I'm going through. And this is what's called a wrap file workflow. So it's raw content direct from the camera that's being brought in. I'm able to play that down. This 5K content, I can do that. This happens to be about 250 to 350 megabytes per second. We can do that across multiple systems. And what we're doing on the back end, again, with that, our technology is we're actually prefetching that data. So as we're accessing this content here, we're pre-staging or prefetching what we're predicting is going to be accessed next based on the access patterns and where that playhead is going, and going to have that ready to move from that NVMe layer out to that RAM layer. So again, not needing to think about where I have to put this. I'm just playing down and I'm getting that level of performance.
And an interesting as well is that prefetch, you kind of think about that as being a forward prefetch. In media, you go back, you forth, you scrub. We actually prefetch in both directions from, say, if you go into a media file, stop there, it'll start grabbing either direction. And then depending on the playback, the scrub, it'll reinforce. It gets kind of it wants to be aggressive. So the more reinforcement it gets that, oh, you are getting content, you are prefetching correctly, it'll then aggressively start prefetching more. So that then just turns to a very smooth playback for the end user because they're not realizing they're not witness to or need to be witness to the actions that the Atlas software itself is getting it ready, staging it for when the workstation actually goes and requests that video content from it.
I'm going to actually switch projects here, but as I do, I want to talk about something here. So another thing that Atlas has the capability of doing is actually running additional services. We call them pods, and they're basically containers that are running inside of a pod that allow you to run different services. We're going to dig into that more in a second, but one that we're actually running here is for DaVinci Resolve. In order for you to share projects, as we're doing between the multiple rooms here, or the way our clients do in a multi-finishing theater or color grading theater scenario, is you need a Postgres database. A lot of our clients don't know what a Postgres database is, let alone how to launch it, so you got to contact IT. Typically, they're setting up a server or a virtual machine, installing that on, or at best, or sometimes not that. We're actually running this on top of Atlas. It's now running in a system that has multiple levels of redundancy. It's running on a high-speed network, and we could protect the file system that this is running on top of.
Yeah, this came from, we would go in, we would set up our system and everything. We'd see this one Mac Mini or some other kind of one-use server sitting there just for hosting this database. And we felt like, how do we make your workflow? How do we make the infrastructure more efficient? That's where this came out of. And then, you had mentioned previously to me at some point of the capability if someone just grabs that thing and goes,
your
project's the cuts.
It's gone. Yeah, the project is the most important part, right? Your media, we know it's protected, it's there, but if you lose that project, that's where all the work went into, right?
Yeah.
So it's a really big deal. I've also seen out in the wild where people will take the workstation that they're working on, one of them, and they'll put the Postgres database on top of that workstation, and the second they go to shut down for the day or restart, everybody loses access to their projects.
Yes, I had not heard that. Yeah. That's okay. Wow.
So here I'm going to go ahead and switch. I'm going to open up frame-based content, and this is really where other scale-out NAS platforms just fall off. They have to throw, for that 5K project, they have to throw a ton of resources, NVMe and hardware, to gain that level of performance, additional nodes. So again, we can actually do this from multiple stations on that tiny amount of hardware that we showed in the graphic in the beginning. So I'm going to go ahead and bring this back. Let's bring this to beginning here, and I'm going to go ahead and begin playing down. So this is one file per frame, about 1.25 gigabytes a second of performance just for the single stream on a NAS platform. So we have to continuously open the frame, feed it to the client, next frame up. We have to do that in order and feed it fast enough. I have a client right now that has four 4K color theaters where four color theaters where they are working on this exact type of content. No issues whatsoever, in addition to having assist edits, mounting the storage and prepping work that's going on. They've got famous directors, famous producers coming in, sitting in this theater for God knows how many thousands of dollars per hour.
Yeah, right.
You cannot drop a frame, right? You're going to lose that client. So we need to make sure that this works. This works in concurrency, and is providing this level of throughput consistency.
One thing to also mention is that Atlas is a NAS solution software. So all of this is happening over NAS protocols. This in particular is SMB. We support NFS as well. So you don't have that fiber channel infrastructure and some of the complexity that comes there as well. So we bring this live to the show because a lot of the times they say, I don't believe you, so we have to show it.
Yep.
So it's really about this. We get a lot of editors, colors coming in and just seeing that smooth scrubbing and immediate playback once you hit the space bar. They're never bound to having to understand the technology, stuttering of content, dropped frames. It really keeps you in that creative workflow, and that's really the media focus that OpenDrives is all about.
So another thing that's really interesting is we just showed Adobe Premiere typically doing either raw content, raw acquisition content, but doing your post-production. And now we're showing things that will be done on the finishing side. So whether that be color correction, color grading and the like, typically people have to separate those workflows because they have storage systems that can't handle both of those, right? Mm-hmm. Or they might have direct attached storage for their finishing side and have, a NAS or SAN solution for their post side. We're doing this on a single platform. So just think of the efficiencies that we're bringing to the workflow by having a single solution be able to handle both of them.
And actually, one thing you mentioned with the previous footage from the What Drives Us documentary, that was the B-raw content. So we also, from a simpler standpoint, when we're just talking about, editorial, we recommend using the camera raw content for the editorial. There's no need to do the proxy workflow, wait for that time frame to happen. You're just ingesting the content and off to the races with the cuts. R3D, B-raw, a lot of these raws will work immediately out of the box, and again, time savings.
Yep. And just even money savings. If you think about a lot of the clients that we have don't have, clusters of transcoders to do this. So they're relying on a station to take their source footage, create their proxies because their systems can't handle the playback on it, and that's waiting to go. Some clients, they can't afford that. So number one, they're tying up that station, but number two, they need to begin working immediately. Think about reality TV shows and the like, or if stuff is coming in, needs to get out immediately. As you mentioned, no converting that footage. You can work on it as it's coming right off of the camera.
To the point you were making about the multiple types of workflows as well, the color editing, everything on similar, there's a big benefit to time to iteration because you can do that. We often have, say, the director coming in, giving notes on a clip on a scene in the morning, and you don't have to copy that data, send it anywhere. You'll have the same compositor, in Premiere, go into After Effects, do some of these things and do a render and replace back in the timeline. So you have the same director seeing the final product, seeing the review done before the end of the day. And I know nothing's ever done. It's only like we ran out of time.
Yeah.
But this allows you to really continue with that creative process and never be bound to, you get more confident about your deliverable and your final rather than, just being cut by the time and not being super happy with the result. So that iteration, that time savings, there's a creative and a workflow savings that comes with that.
So we're showing the performance. Let's show the ease of use. Let's show the actual Atlas interface. So for that, I'm going to open up my web browser. That's typically how you're going to access Atlas. If you are comfortable with command line, you could do that. But everything we're going to show you here today is actually also accessible via API. Really important as you're going through the show. There's man vendor after man vendor, PAMs
Yeah.
are popping up, automation tools. Everybody's trying to figure out how to make their workflow more efficient and tie into many other tools. By having an openly accessible API, opendrives.com/API, you can go see what's published. You can gain access to connectivity to, you name it, MAM systems, automation tools. Can go in, they can access data, they can trigger different events within the storage platform. So really opening up that ecosystem beyond just the storage side.
Yeah, we cover a lot of different media work cases, use cases, VFX, editorial, color. There's differences in workflow and product procedures, even customer to customer. So we have our customers tend to, if they want to specialize, if they want to code to it, they'll leverage the API and not have to do a lot of the manual clicking to provide that automation. Again, excelling in their workflow, which, that's what we want to solve. We want to work with everybody to drive more efficient workflows.
So when I come into here, we see our dashboard, right? So dashboard is typically when you have information you want to see right away, like, right in front of you. So I can see here, most important, my system health. Everything is in the green. So we use a stoplight approach, green good, yellow warning, red bad. I can see everything's in the green. If I click on here, I can dig in. My pools, my physical storage is all in the green. I can see my file systems are all good. My network connections are good. And we do support HA, or what's called high availability. So if we had HA, we don't have it at the show today, this would be in the green as well. As mentioned, we also support scale up. So the solution we have here today, let's say you started out with that, you can expand the system by adding additional storage modules. That's going to increase your performance and increase your capacity. So we're able to really fit a solution to what the needs are today, but understanding that you can grow that when that budget or when that needs arise. Maybe you can't afford HA today, but you add that later. Or maybe I have a certain performance and capacity need today, and things go great, you wind up doubling in size. We can add modules to that system to support those workflows. And we also support scale out. So if you grow beyond that, we can add additional, cluster these systems together to get even more performance. So notifications. Notifications, obviously I can see inside of my GUI, but also I can get it emailed, obviously. We also support Twilio for text-based notifications, and we support webhooks for push notifications. So if you want to get a Slack message of these notifications, it's possible as well. As I scroll down, I can see my free versus used capacity on this particular system. Because it's hybrid, I can see my hard drive pool, and I can see my small flash pool over here. This is also true single pane of glass. So right now I'm seeing one system, but if I've got multiple systems, maybe in the same location, maybe in different locations for any kind of multi-office scenario, or maybe a disaster recovery and business continuity scenario, I can continue to add those additional systems. If they're local, I can see them here. If not, I could just type in an IP address, and it's going to aggregate the information. So I'll be able to see my capacity availability across my entire environment, and then broken down on the right-hand side of here by pool. So really nice feature. I'm also going to see, right now I'm seeing bandwidth information because I was go ahead and playing back while that was going. So I'm clearly not the only one playing back right now.
Normally, one thing to mention about that single pane of glass, otherwise you'd have 800 tabs
Correct.
open across, and
Yes.
then you might get lost in which one you're doing. So being able to drop down support, there's even the eye that you can, hide and show within the actual login infrastructure. So you can really log everything in and just see what you need to be able to address on.
So back to our dashboard. On the left-hand side is our navigation, and one of the things that OpenDrives, our developers and our engineers have done, and it's not an easy feat, is create an interface that's really accessible by different clients. Our clients have different levels of technicality, and we've got smaller shops that don't have dedicated IT staff, to enterprise customers that have dedicated infosec teams and storage teams, and we needed a solution to not be a puzzle castle, be able to be easy to navigate, easy to get to where you want to go, and not have to hunt around and spend time trying to figure out, where is this particular feature. So I'm going to go ahead and just extend this out so I can see the names of the areas that I'm going. Really nice, neatly organized. So let's start with storage. And realistically, this section here called local file systems is really where my users are pretty much on a daily basis. They get awarded a project. They want to create a dedicated file system for that. In this page here, I can see my existing file systems. We get a nice little explorer here. So if hey, do I want to see what's inside of any of these folders? I can do that without mounting anything. I can see my frame-based files on here. But I want to go ahead and create a local file system. Really easy to do. Hit create local file system. I select my pool of storage. If I was in a single pane of glass scenario, I can pick my system and then pick my storage pool. I go ahead and give it a name. And here's where we're showing that we are multi-protocol. So being in a NAS system, we're going to be able to support SMB from 1 to 3.1 multi-channel. We're going to be able to support NFS. We're going to be able to support S3 as well. So SMB typically is going to cover your Mac and Windows systems, NFS for your Linux systems. The interesting thing here is the S3. As we're getting more cloud-native applications, there's a lot of man vendors out here today, we're able to provide a system where your editors could be working and your cloud-native applications could be accessing that same content while it's going through. Then we could set quotas. So if you have, say, 200 terabyte solution and you want, say, limit that capacity to just 20 terabytes, you can put that in here. That'll be a hard set limit for that user. You can go ahead and change that. Or we can do a reservation. So let's say you have that shared 200 terabytes across every file system, but for this particular one, maybe you want to guarantee 50 terabytes. You've got a project coming in, it's going to be at least that. You want to reserve that, so you can go ahead and set a reservation.
Yeah, within quotas, even if you don't want to restrict the project or the group or the department, we often see our customers leverage this, enable it, and set some kind of, whether it be 20 terabytes, 50 terabytes in there, because by default, the end clients, the workstations, the Windows, the Mac workstations, you can see the entire capacity of the storage system. And when people see free storage, they try to use as much as they can from it. So oftentimes this is a little bit of a, you think a little bit about, does it really deserve to be pushed out there rather than throwing the kitchen sink at everything? It's a way to kind of data manage more
from the user standpoint.
Exactly,
yeah.
Exactly.
Yeah, the end user standpoint. The other interesting thing is I feel like chargeback models. So if
right.
you are a large organization and say you are creating file systems for different subdivisions or projects, maybe you charge by capacity for a particular project coming in. Oftentimes some of our clients will work on a project, it's a rush, and then their end client might not come back and for a couple of weeks, and it's just sitting there. If they're doing a chargeback model, it's really easy for them to limit, say, hey, we're going to charge you more money if we expand this out, or they know exactly how much they can charge because they've limited that capacity on that side of it. Mm-hmm. Let's take a look at some. Normally you would just click create, but I want to dig into some of the advanced settings here because there's a couple of tools here that I think are pretty differentiated. One is compression. So we're a fully inline cache system. As data is coming into that caching layer, we're doing a quick taste test to determine is the data compressible or not. Most systems in M&E today that were really designed for IT, they will suffer a performance hit by enabling compression. Our solution, if the data is not compressible, it's not going to be compressed. In that frame-based use case that we saw before, you're going to get some really great compression on there. But if you think about even in a compressed workflow, all of the files that are associated with that, your project files, your graphics files, Photoshop and the like, all that data is compressible. So being able to do that, you're going to see a nice capacity savings. And in that frame-based use case, you're actually going to see a benefit on the reads of that because of how we're promoting that data.
Yeah, and this is storage-based compression. Like
Correct.
You're not actually compressing any of the content itself. It's lossless. It's the same file is going to come out of the same. This is done at a lower level, in the file system level of that compression.
Yeah, so you don't have to worry about any of your images or your quality getting adjusted at all.
Exactly. And as well as a lot of the other systems are post-compression or post-compression where it's saying, okay, after a while, after it's already stored, let's go back and look at, see if we can have any benefit. That then post-process type of compute that's happening on that data also now conflicts with the other users who are actively using it. So this is all done in line on the fly, so you're never bound to, affecting somebody at a later date because now all of a sudden the cycle has hit to where we're going to go do all this post-process on the data.
Record size is another interesting one. So we find writing big 1 meg chunks for your data is most efficient for those big video files. But what about all the other documents? You mentioned an XML file before, or a Word document that's coming in. It doesn't make sense to write in these big 1 meg chunks. So we're actually able to, as data is coming in, figure out what's the best record size for that content going into the system.
Yeah, with that, I mean, it stores it more efficiently on the drive. Some of the systems have a fixed record block, and when you write that small, say, 7K XML EDL file, it might take up that whole space, that whole 1 meg block. You've got to read through a lot of zeros to get to then the next file because it's stored in that small record and packed together with the other giant 1 megs of the actual video. You end up getting a more efficient playback because it's not reading a lot of data to see if it's useful, as well as the operations to make it more efficient to fit into the 1 meg all have to happen use CPU and RAM, so there's a whole lot more operations there. So this really drives more efficiency.
Snapshots. So snapshots are actually how we protect the file system. We're going to dig more into about snapshots, but right now they're hidden. You can actually expose that to your users. These are block level snapshots, so it's not actually saving copies of that file. It's just not removing the changes of what's happening on that data. They are instantaneous. There's no performance impact. It provides a nice way of point-in-time recovery. So let's say I accidentally wrote over a project or deleted something.
Yeah, and at the show, I often have people ask, you're okay with having all this content here? You have a whole bunch of people doing demos, accessing the data. What if somebody deletes something? Are you worried about it? And I said, no, because we're using snapshotting here. So we'll just revert back. We'll go in, we'll grab the files that were accidentally deleted, drag them back in to the production file system, and then we're off to the races again. So yeah, I sit in comfort knowing that we're protected on the back end.
Yeah, the other interesting thing is, snapshots are read-only. So it provides you a safety or mitigation against ransomware coming in. So you're able to, if God forbid you get hit, you can actually do that analysis and figure out, because it's a slow crawl that typically happens, you're able to actually figure out and analyze, since they're instantly accessible, the states of those file systems, where those files are clean, and then you can go ahead and begin that restoration process. A lot of other solutions will have to air gap copies on tape or send data to the cloud. Still a good idea to do, to have off-site copies, but when you actually get hit, the process of analyzing something that's in the cloud where you have to egress that content out to do the analysis is going to cost you money. Or if it's on tape, you're in for a very time-consuming bulk ingest, restore, analyze, no, not that, next series of tapes, and going through. So this makes that process, again, hopefully never happens, but makes that process a bit more streamlined. So from there, you would go ahead and hit create. It would create the file system. You're now ready to go. Next down on the list here, we have snapshots, just to dig into that a bit more. I can see my snapshots here. I can view by date. I can see my largest ones here. A lot of my users are in here because they're running out of space and they want to get rid of some snapshots. Call your OpenDrives person. They can help you out with your capacity on here. But as you can see here, so let's say I wanted to see what my differentials are. What is in this snapshot? This view is great because I can go ahead in. I can compare when this snapshot was taken to my current live file system or even other snapshots. And I can see exactly what was modified, created, or removed from the system in a nice, clean view.
Yeah, when you talk about the capacity, the usage of those snapshots, that is the delta change from the point in time. That's probably something to is that when the snapshot's taken, it's just immediately, boom, here's this checkpoint, and then all data, all changes, all the deltas are what use up capacity. So it's not like a clone where it's a block for block copy. It's only the changes, and so yes, these are the deltas they're looking for. What's some data we can free up? You know what? We can just collapse those snapshots together and free up some of those deltas to remove that space.
Yeah, and some other systems that we have out here today don't have snapshot capability. You have to do like a file level based file replication, meaning you have to have
the full file.
Okay. So meaning you have to have 2 to 3 times the capacity of your source in order to do these types of file-based replications. Even something as simple as I change a permission on a file, that's now a new file, I have to make another copy of it.
Oh, wow.
So really inefficient. With this solution here, especially in media entertainment, super efficient way of protecting your system, low tax, because the biggest files are your media files. So that means that they don't change, they're non-destructive. Just new data or changes to projects and the like that are coming in that are going to be reflected here. So the snapshots are typically small unless you're deleting an entire project. That's when you get to typically see a larger snapshot. So here, if I continue down, let's go to mount management. It's one of my favorite features. So mount management is our ability to mount other file systems. So one of the things that we can do is we can actually mount S3 buckets. So this can be an S3 bucket in the cloud. This can be a local object storage that's on here. We're able to take that data, and then once it's mounted under our platform, we can reshare that out as SMB or NFS. For those who are familiar, that's called a cloud gateway. We're providing that service as part of Atlas. So you don't need any other third-party tool. It's now mounted and accessible. This is really great for self-service archive type setups, right? So where maybe I've got an archive in, maybe Wasabi or your Backblaze, you name the cloud provider. My user can now see that, right? And they could see folder hierarchies where that doesn't really exist in S3. It's
right, it's an object, just a whole giant list of objects, files. We translate this mount into a folder, and you can drag and drop through Finder, through Explorer, just as you would anything else, and not even know what's actually on the back end of it.
Correct. And we have a number of the hyperscalers and cloud providers over here. Some of them charge egress fees, some of them don't. If they do, a nice thing that we do is if you're accessing a data that's stored in S3, it's actually going to cache that locally. So any subsequent calls from that, you're not going to have to get charged egress fees yet all over again. Any subsequent calls are going to come from that cache.
Yeah, that's great for onesie twosie. If I want this file, I can just go access it, open it from that, and not deal about unarchiving it, bring it over. It's going to get that very low latency response because it is, through caching, going to be either in RAM or in the NVMe layer of the pool.
Yep. Another interesting thing is we can mount other NAS systems. So if we can see it as SMB or NFS, we can mount it under our storage platform. And then there's typical two use cases I see for that. One is data migration. So let's say you're putting us in to replace an aging system or perhaps a system that's not fitting the performance that you need. We can mount it under our platform and then create an automation, or we call it a routine, to migrate the data from that file system to our system and do that at the fastest backend connection to our system. Most people today, when they're doing data migration, they might have a 10 gig, if they're lucky, client mounting both systems. Now that system is tied up, and if it's terabytes or petabytes, say goodbye for a couple of weeks or months on that system while it's copying everything over, right? So we're able to come out of the fastest backend, storage to storage, free up any stations that would normally do that, and automate that entire process. More, I think, really interesting, I should say, is we can actually mount other systems. Let's say you have some support life left on it. And we actually have a client that's done this. So we replaced an existing NAS-based system that they had, but they had a year left of support life left on it. So we talked about this feature. They said, hey, we'd love to see you guys mount it. So we mounted it under our storage platform and reshared it out through Atlas. Because of how we're doing our caching and our prefetching, they're now seeing a 30% increase in the performance of their old NAS system. So extending the life of it. This is really big for just as a company than any other solution. If you think about, going in and, hey, we're going to replace it, get rid of those guys. No, we're saying, hey, we're going to put something in that we know is great, but if you've got something that you can use, let's use it. Let's work with it. Let's, let's make it better. So I think this is a big differentiator for us. We've now seen it live in action. Clients love this feature.
I mean, even today, I had somebody asking, do I have to fully rip and replace? And it was, no, we want to work with you because we know that was a significant investment you had 3 years ago or whatnot. Let's see how we can, move it to a nearline archive or make it pass through, like you're saying in this as well. I mean, that's definitely something we want to. Being, customers at some time ourselves, wanting to leverage our expensive purchases. We get it.
Yeah. Go rip it out. No, I can't. I can't
you.
do that. Next, I have my network tab here. Normally, this is where you're doing any kind of configuration. This window is pretty interesting in being able to, set up, do things like create bonds, break bonds, redo for any kind of mobile solution. So some of our clients have these in a broadcast truck, or they have these on a mobile rack because of our unique form factor on our Ultra product line. Very shallow, only 20.1 inches on the deepest module. And we're able to, low power, so we can keep that on standard 110 volt power, allows it to be very mobile. But the interesting thing about this is I don't need to have a complicated networking setup. I can do so much in the GUI here, just going through without, I've had other systems where you have to have a PS call to go in just to change an IP address. It's like a huge deal. this is a really nice way of simply doing that for a client can self-service.
Yeah, some need a reboot of the whole system.
Yeah.
And that's very, in a production environment, yeah, that's a no-no.
That's a big deal. So in here, I can see any kind of shares that I have, my SMB shares. I can see my NFS shares, my S3 shares, and the like. In terms of administration, so access controls. If you're a smaller environment, or maybe this is a mobile system, we give you a nice little GUI here to create any local users and groups. If you're a larger organization, we do support all the major authentication providers. So that's your Active Directory, that's your LDAP and Kerberos, and we do support single sign-on tools for GUI access. So your OAuth and SAML are supported. And we also support role-based access control. So what that means is we can actually create roles, assign them to groups or to AD groups, and really granularly limit access to what you're seeing here. So maybe you have a scenario where you have some sub-admins or some users where, hey, I want to give them access to maybe create some file systems, but really not touch anything else, right?
Or like a view-only mode where you can see how everything is, but I don't want you to be able to touch anything.
Yeah, exactly. So you can create what's called RBAC, or those role-based access controls. You can go ahead and set that up. Another interesting thing is boot environments. So boot environments, we have some clients, some enterprise clients, where they have sandbox environments because they don't have really any tolerance for downtime. They can't suffer a new update coming in and disrupting their workflow. So they have to test everything prior. And this is actually how our internal teams test different versions of software. So this, in essence, is creating a snapshot of the boot environment. And I'm able to, if I say, hey, I'm in this version here that I'm running now, I need to roll this back for whatever reason to a previous version. It's literally as simple as activating that and rebooting that node into that environment. Does not affect your data, that's separate. This is just the state of Atlas at that time. So that's great from a sandbox environment, testing out different versions. But what's really interesting is it's saving all the state of Atlas at that time. So again, we have these in mobile trucks, we have these in flight kits. Some of our clients are going maybe from stadium to stadium, same IP ranges, same IP setups. Instead of going in and creating all of these changes for each and every single thing, I do it once when I'm there. I can manually create a boot environment of that. The next time I'm at that location, reboot in that boot environment, all my network settings are there and I'm up and running. So saving a ton of time.
This is a big one for the enterprise customers because the past experience was, I'm doing this upgrade, there's no going back. So if there is something broken or not working or a bug that gets exposed, you're now waiting for the next patch on top of that to then fix the issue there. So this is one of those, we go there, if something gets exposed, there's a bug or, whatever is there, let's just revert back. Boom, back old state. We'll figure out what was going on, and then we'll try again during the next actual maintenance window.
This is funny. And, when I first started in the SE side, so I've been in media entertainment for a very, very long time. But when I first got into an SE position, my previous storage company, I don't want to name them, but 6 months in, my client found the bug. They had upgraded to the latest and greatest version, and they found this Photoshop bug. Every time they opened up a Photoshop file, it would kernel panic the station. So I had to have a very uncomfortable conversation with my client of saying, hey, if you want to work on Photoshop, even though I sold you this expensive system, I need you to copy that off to your local hard drive, work on it, and then copy it back. It took 6 months for the company to create a fix for this issue.
That's fun.
Yeah, it was a good time.
Yeah.
So with something like this, they could literally have rebooted and been working fine, and
and we'll deal with it later once we know everything's settled in the 6 month period.
In the 6 month period. Yeah. Next, let's talk about tasks. So we have routines. Again, this is automation in the storage platform. So we do have a wizard here, and this is our snapshot wizard. So here's where you can go ahead in. Really simple to set up snapshot routines. I can set up snapshots, again, every few minutes, hours, every few days, every few months, specific days of the week. And snapshots can occur either on an entire pool of storage or on a specific file system, right? Typically, they're stored locally, but we can also store them, we can also do replication. So this is great for any kind of disaster recovery scenarios, right? The really unique thing, interesting thing here is we're utilizing our checksumming technology with replication. So what that means is if I'm in a scenario where I have an office, say in New York, and maybe I'm sending data to LA, for DR, and we can maybe send to one pole there and vice versa. That's a high latency connection. There's a high likelihood where some data can get affected as it gets transferred on that end, and unlike other systems where I have to keep doing these source and destination checks, we send the data over. If there's an issue on that receiving end, with the checksum, the technology that we have, it's going to self-heal on that end. So,
and yeah, that's something we haven't really talked about. Like the entire file system, all the data is checksummed. Those checksums reside in different sections than the data itself, whereas some are the same disks. And then those checksums are checksums. So this kind of tree and recurrent checksums ensure a consistent data set. From that same point, when we're leveraging for the replication, we're just sending over the full data set. It's just the ones and zeros of blocks. We get a lot of performance because of this. We're not bound to doing that, enumerating each file. Like in rsync, you're doing that individual, I have to read this file, metadata, doom, send it. This is just the entire data set, the entire change data set too. It's not even the full, other than the first copy, every other copy is the delta changes. And so you go in there, you run through the hashes, make sure all the checksums are good to go, and then you're consistent. You're in your stabilized DR environment.
Yeah, and we didn't talk about this, but from a local, from an end user standpoint, a lot of them don't understand what checksum is, right? Again, we want our creatives to be creative.
Well, if they're camera capture, they definitely know what checksums are. MD5, XX hash.
Yeah, but
it's a different thing,
most
right?
editors don't. Yeah,
well, the editors.
Most editors don't. But we've all been through the scenario doing a transcode, right? So you do a transcode, long form transcode, you QC that, somebody's sitting there watching it, get some weird artifacting in there.
Green line.
Yeah, green little macro blocking and
Xan times.
Yeah. What happened? Nobody ever thinks about it. They just do it all over again. That's hours worth of time wasted, right? With it, our ability to be able to self-heal, we can help mitigate that again from happening, literally potentially saving hours of time for that end user.
Yeah, that's self-healing, not only when it writes the checksum, when it's reading back, it verifies, and this is more of, I guess, signaling issues, right? If there's a issue with the cable, it'll ensure that it can do the checksum verification before it sends it out the NIC to that client.
All right, so let's talk about another great feature, containerization. As we mentioned before, we're running a pod, which is a collection of one or more containers. One of the other pods that we're running is our OD Stats Dash, which I could show over here. So here we have a pre-built dashboard utilizing Grafana with a back-end database. What's nice about here is we've given what most clients want to see on the system in terms of analytics. I can go ahead and scroll through a ton of analytics that are beautifully displayed on here. But with that back-end database, you could do things like capacity planning. You can see how much performance maybe you use in a particular project. Do I have enough? Do I need to add more to the system? So it really helps you out.
Yeah, the dashboard has a lot of the significant, just basic analytics you want to see about, okay, we good? How's my capacity? What's going on? If you want to drill down into the subcomponents, IOPS, per disk performance, and kind of analyze your workflow and IO pattern, this is where you go to. And it looks pretty with the colors.
It does look cool. Another one that we're showing here is Discover, and this is pretty interesting in that this is giving you more file level analytics, right? So I can see all of my folders, how much capacity is in each folder, but hey, what's eating up the majority of my capacity here? It's my Blackmagic raw content, my B raw content, my EXR content. I can see what's hot and what's cold data. Now we take a bring your own license model to this. So if I go to my recipes, we basically have a curated list of applications that our clients have asked us for, that our partners have asked us for, to provide you a way of launching these in a matter of 2 mouse clicks. Some of them are open source and free. Others require a license that you would get directly from your partner or the manufacturer directly, but instantly launch these in 2 mouse clicks.
Yeah, it's really like a curated marketplace of tested workflow uses where a couple clicks, depending on the application, we have a license, a directory, some kind of variable that we attach to it, and then you just click it, test it, make sure that everything's consistent, and then you're off to the races with the application running directly on the system with local access to the data. I mean, you pick which data you want it to see, not necessarily everything, but that's part of the whole infrastructure and the power from it.
Anyway, thank you everybody for joining us on this quick tour. If you are interested in getting a more in-depth tour, happy to do this demo. We can do the same demo from anywhere in the world, utilizing, again, real gear, no smoke and mirrors demos. Reach out to us, and happy to set that up.
Absolutely. There's a whole lot more to it. We'd love to hear about your specific workflows because that's what we want to solve. We're all media and entertainment, and we all come from a background with it. We want to solve those workflows. So please reach out to us, and we look forward to talking to you.
Thanks, everybody.